Hi, this is Alex from devstories.eu. Docker Masterclass, episode 12 of 18. It works on my machine takes on a whole new meaning when your local machine uses an ARM processor, but your production cloud runs on Intel. You test your container locally, push it to a registry, pull it on the server, and it crashes instantly with an execution format error. The problem is a hardware architecture mismatch. To fix this, you use multi-platform images. A container image is fundamentally a bundle of binaries and file systems. If you build an image on an Apple Silicon Mac, the resulting binaries are compiled for the ARM64 architecture. When you deploy that image to a standard Linux server running an AMD64 processor, the host CPU literally does not understand the instructions inside the container. Historically, you had to maintain separate build pipelines for different hardware targets. Docker Buildx removes that requirement. Docker Buildx is a command-line plugin that extends the standard Docker build system. It uses a back-end engine called BuildKit to execute builds concurrently and handle complex tasks like targeting multiple platforms in a single pass. When you build a multi-platform image using Buildx, you are not stuffing two separate file systems into a single giant container. Instead, Buildx creates a manifest list. Think of this manifest as a routing table. It holds a list of pointers to different architecture-specific images stored in your registry. When a machine pulls your image, its Docker daemon reads this manifest, identifies its own host CPU architecture, and automatically downloads only the image layers that match its hardware. To cross-compile and package a backend API for both architectures simultaneously, you use the Docker Buildx build command. You include a platform flag, passing it a comma-separated list of your targets. For example, you type the flag followed by Linux/AMD64, Linux/ARM64. You append your standard image tag, and then you add a push flag. Here is the key insight. When building for multiple platforms at the same time, you cannot just load the final multi-platform image back into your local Docker engine cache. The local daemon is not designed to hold a manifest list pointing to multiple architectures. You must instruct Buildx to push the results directly to your container registry. The registry acts as the storage system that correctly organizes the manifest list and the individual architecture images. To physically execute the build for a processor you do not have, Buildx relies on an emulator called QEMU. Docker Desktop configures this automatically. When your ARM machine reaches a step requiring an AMD64 instruction, the emulator translates it on the fly. This requires zero changes to your Docker file. If you need faster build times, you can also use cross-compilation tools directly inside a multi-stage build, which skips emulation but requires setting up specific compiler flags in your code. The true power of a multi-platform manifest is that it completely isolates the consumer from the underlying hardware details. A developer on a Mac and a production cluster running Intel pull the exact same image tag, and the registry serves each the right binary automatically without any extra configuration. Thanks for spending a few minutes with me. Until next time, take it easy.